Right, so I've brought our y-intercept and our x-intercept from our previous video. We are back with some quick math. We are doing cubic functions. This is pure math, technical math content. Like the video, subscribe to the channel, and share it with anyone in grade 12 doing pure math or technical math. Right. This video we are spending on our turning point. So we're busy with the turning point of g. Right. So let's just think quickly about a function, any function. We're dealing with a cubic function, so maybe a cubic function. Over here we are increasing, right? So if you are walking on your function, you're increasing over here, and then there gets to a point, let's get that back, there gets to a point where you over there at the turning point. Okay, and then after the turning point you start decreasing. At the turning point, you're over here again, you are flat, and then you're increasing again. All right, so that's my point. My point is, at our turning points it is flat. And because it is flat at our turning points, what we should know is that our gradient is equal to 0 because it is flat at our turning points. What we should know is the gradient at our turning points are 0. Okay, so what is gradient? Gradient is derivative. Okay, so we know that the gradient, the derivative, is g prime x, and we know that at the turning point our g prime x, which is our gradient, will equate to 0. Okay, so that's what we're doing in this video. Let's first find g prime x. So we should know the power rule, right? And the power rule tells us exponent multiplies with coefficient. So over there, my exponent is minus, or my exponent is 3, and it's going to multiply with the 1, which is the coefficient. Exponent times coefficient, so that's going to be a minus 3x, right? And then we subtract, we take 1 away from the exponent. So the exponent was 3, the new exponent is 2. Okay, great. We look at the second one over there. The exponent is 2, the coefficient is 5. So the 2 multiplies with the plus 5, and that gives us plus 10x. The exponent was 2, we take 1 away, so the exponent is now 1. Okay, right? Exponent times coefficient, subtract 1 from exponent. So we're going to say plus. The exponent over there is a 1. The 1 multiplies with the 8, that gives us an 8. X to the power of 0, that's going to disappear. Right, and then this last term over there, which is our constant. So you know the derivative of constant is 0. If you want proof of that, we earlier or in the previous video spoke about the fact that there's x to the power of 0 next to the constant. The 0 multiplies with the 12, generating 0, so that thing disappears. Okay, right, we know that it is there. So what we've done was we found g prime x, and now we want to know where that is equal to 0. Okay, so okay, let's just do this. We're gonna take this thing here. All right, let's copy it, put it over here. All right, so we're gonna take that, and we need to equate it to 0. So we have options. We can try to factorize this, or let's go with the quadratic formula. Okay, so we're gonna say x equals minus b plus minus, that's a minus, square root b squared minus 4ac c over 2a. All right, so we're going with the quadratic formula here. Let's do that. Right, that's nice. Our b value is going to be this positive 10. Okay, so it's going to be minus comes from the formula, minus b plus minus square root. B is at positive 10, b gets squared, so I'm going to go straight and write 100, because that's what 10 squared is, minus 4. My a value is minus 3, so I'm going to put a minus 3 in there. My c value is this positive 8, I'm going to put that in there, and divide all of this with 2 times my a value, which is minus 3. Right, so I would suggest you go put all of this straight into your calculator. I think I'm going to do one more step first before I go to my calculator, just to simplify what's under the root here. So I'm going to say 4 times, well, negative 4, in fact, negative 4 times my negative 3 times my 8. That's going to give me a 96. Okay, so I have under my root 100 minus 96. Divide this, negative 6. Okay, that was easy enough. Okay, because my values look so nice, I'm going to go ahead and continue without the calculator. So this is going to be 100 minus 96 is 4. Divide this with negative 6. So this is going to be minus 10 plus 2 divided by minus 6. or minus 10 minus 2 divided by minus 6. Alright, so that is going to give me a negative 8. Negative 8 divided by negative 6. Let's just simplify this to minus 4 over 3. And this is going to give me a minus 12. Minus 12 divided by minus 6. Minus 12 divided by minus 6 is going to give me a 2. Okay, so what did we just find? These values that we found, this one and this one, these are the x values of our turning point. Okay, these x values have a 0 gradient. Okay, these are the x values of my turning point. In order to find my y values of my turning point, I need to take my x values which we found and go put them back into our original function. Okay, so we're gonna go put g of minus 4 over 3, all right, and then we're gonna go say g of positive 2. All right, so I'm gonna take a second to put all of that into my calculator. So where's my function? Let's just see. I'm gonna go put those values back into this function over here, which is g, and then I'll get my answer quickly. So you take a second to put that in on your calculator as well. So minus the first value, I'm going to just put 2 because that's what I can remember right now. Cube plus 5, my 2 squared plus 8 times 2, and subtract 12. All of that gives me 16. Okay, so this one over here is 16. And I'm going to do the same thing. This time I'm just going to, inside my substitution, have a negative 4 over 3. Okay, so again, a negative 4 over 3. This is just calculator work, so take a second to do that on your calculator. Negative 4 over 3. And the answer that we get, I'm going to put this in decimal form, is minus 29,19. Okay, so those are the two values, this over here and this over here, two coordinates rather of your turning point. We'll stop there. In the next video we'll draw.